Quality control in swing. So in this module, I will be highlighting the areas. In those areas and by using those methods, the quality can be assured, and these are the processes to control the quality in swing. We talk about the quality. Quality has multiple meanings. So I don't want to discuss about the quality here, but out of those multiple meanings, two of those meanings are critical, not only to quality planning but to strategic business planning as well, namely product performance and freedom from deficiencies. Quality control in swing. This system describes how monitoring of quality is an ongoing process and not merely a control mechanism. The approach of this method of quality control is to proactive rather than corrective. The entire system revolves around building quality into the garment, not inspecting quality into the garment. There are some inspection guidelines. I'm going to discuss about those inspection guidelines here. The sewing defects begin and end with the operator. It can be noticed that in most cases the operator is not aware of what is required from him or her in terms of stitching quality. It is thus imperative that one sealed sample, that is sample as per order, correct fabric, trims, etc., be available and easily accessible to all operators at the shop floor. In case of certain garment parts that require a skillful operation or for a critical operation, the operator should be given a sample of the same for their ready reference. The broad objective of this is there should never be any legitimate reason for someone not knowing what is happening. The three-part system is suggested to be used in sewing room. The components of the three-part system are in-process sampling. Second one is 100% inspection, And third one is quality audit. In process sampling, sampling is more economical and feasible than checking everything. A proper sampling system can give results that are closely representative of actual situation. Attention can also be focused on areas where defects are being produced. The objectives of in-process sampling are maintaining a steady or tight control over all operators and concentrating attention where poor quality is being produced. In this case, inspection guidelines are: the inspector should be a person not directly responsible for production. The inspector should have adequate knowledge of the garment being produced in terms of tolerances, stitching details, workmanship quality required, and manufacturing standards for the garment. All operators, if possible, should have a quality specification sheet at their workstation which describes the part or parts they are to stitch together, the workmanship quality pertaining to that particular part, for that is a straight seam or a curved one, or any quality problem that are likely to occur at their particular operation. The tolerance pertaining to their sewing operation. This information should be available to the operator at their workstation where it is easy to read and should be legible, that is neat, and if required in the local language. It is the responsibility of the supervisor that each operator understands his or her specification clearly before production starts. The main features of the system are: the inspector moves around the sewing room, visiting operators or operations at random. He or she takes a quantity of garment, usually a bundle. From the bundle, he or she selects a given number of garments or parts of a garment and checks them against the specification of the operation concerned. If the parts are duplicated, as in two sleeves, two parts correspond to one garment. The findings of the check are recorded on a sampling record. The number of garments selected for checking should be laid down for each factory. Depending on the results of the check, the whole bundle is accepted as being of satisfactory quality or rejected as being unsatisfactory. The rules which decide what constitutes a satisfactory or unsatisfactory bundle are laid down as part of the factory system. Accepted bundles should proceed to the next operation, and rejected bundles are passed to the supervisor for action. When the supervisor gets a rejected bundle, he or she assesses the problem and instructs the operator to repair the defect and check the rest of the bundle. The supervisor also seeks and rectifies, if possible, the cause of the defect. The operator who has shown the rejected bundle now comes under a procedure called clearance, which brings the operator under a closer scrutiny than the usual random sampling. This continues until the operator is cleared by steady good production. Under clearance, the operator returns, and in fact the inspector returns to the operator after a short interval and takes a recently completed bundle and bundles. These bundles are checked and accepted or rejected using the same rules as for the random sampling. The operator is cleared when a given number of bundles are accepted. This number is called the clearance number. During clearance, accepted bundles are passed on to the next operation, and any rejected bundles are given to the supervisor for action, as with any faulty bundle. When the operator has been cleared, he or she is not checked again until her name comes up in the normal random sampling procedure. In this way, the inspector keeps checking an operator whose quality is bad while still going around the factory checking other operators. Of course, neither the inspector nor the supervisor is expected to calmly allow an operator to remain uncleared for quality for long. The supervisor will speak to the operator on the first rejection and should take urgent action after a second rejection to find out what is wrong and cure it. An important point of this system is that no time does the inspector return the work directly to the operator. Only the supervisor returns work for repair. He or she is responsible for her section and should see all work that is being returned. He or she will then judge the reason for the defect and take the appropriate action dealing with operator, machine, cut work, etc. The ideal situation is where the supervisor feels that the inspector is there to help her by finding quality problems for her before they become serious. And when installing a sampling system, this attitude must be introduced from the start. The supervisor should be educated to see the inspector as a helper, an extra pair of eyes, not someone there to create trouble. Unless the supervisors and inspectors cooperate, the system will not work. Apart from this relationship with supervisor, the inspector must be able to understand what he or she is looking for, interpret quality specifications, and have sufficient confidence in her own judgment to insist that a mistake is a mistake, even when the supervisor says that's not too bad, it can go on. Parameters. There are four parameters that need to be done before starting in process sampling. First is called lot. Lot is a collection of garments from the sample has to be taken. That is one bundle, etc. Sample size. The number of garments parts to be taken for inspection from the lot, that is 6 garments from one bundle of 25 pieces. Acceptance number, the number of faulty garments or parts that a sample may have without the entire lot being rejected, that is 0 out of 6. If there is even one defect or defective in the sample, the entire lot will be rejected. Clearance number, the number of lots that must be accepted in succession to take the operator out of clearance procedure, that is one lot. 100% examination. 100% examination is the process to check all stitched garments and some garment parts in production. 100% examination should be done within the line at the end of the line. Objectives. It prevents defective garments from being passed. It repairs faulty garments and remove the cause of defects. It is likely that after the in-process sampling, some faulty garments will be produced. The objective of 100% inspection is to prevent faulty garments from being passed as imperfect. Examination is a stage in the production sequence and is normally regarded as an operation. Most factories examine at the end of making operations and sometimes at the end of finishing. In other factories, examination is combined with thread trimming. On one hand, the trimmer is going over the seams anyway, and he or she may as well examine at the same time. And on the other hand, trimming and examining call for different types of operators, and some operators tend to trim and forget to examine. Whether or not these operations are combined depends on the personnel of the factory. Examination points. For economic reasons, there should be as few examination points as possible. On the other hand, for easy repairs, examination points should be replaced before any operation which overshoot an earlier one. To reconcile these opposing objectives, it should be considered how many defects are actually being produced by each operation, how many are found at the examination point and whether or not these defects will show in the finished garment. The usual position for inline examination points is after a critical component has been made before attaching it to the main garment. For example, after mixed collar. Inspection guidelines: 100% inspection within the line at the end of the line. The inspector should be trained to inspect. This implies that there should be a predefined set of actions that he or she undertakes to examine each garment or part for visual measurement and workmanship. Examination tends to be a boring job, and any inspector can become mesmerized after a while and simply not see what he or she is looking at. To avoid this, an operation description must be written for this job, detailing how the inspector checks the garment. The inspector should be positioned within the line similar to a sewing section. His or her workstation should be adequately large to handle the garment part that is to be checked, and reports and other work aids to be placed that he or she needs to carry out the inspection. The inspector should have adequate authority not to proceed a bundle to the next operation in case faults are found. He or she under no circumstance should be harassed by the operator to pass on the bundle just because the production target for the day has to be met. Quality audit. Quality audit is an examination of small number of garments from finished stock from sewing. These are taken as representative of the quality going to finishing room. All end-line checkers are audited individually 4 times in a day to ensure a control on checking efficiency of end-line checkers. The objective of quality audit is to check the other parts of the system to obtain figures which can be compared with figures of in-process sampling and final inspection, giving comparisons of the effectiveness of the above two systems. To look at the garment from the customer's viewpoint and analyze results. Inspection guidelines. The auditor for the sewing floor should be qualified and experienced quality controller and should be able to check a garment thoroughly as per buyer specifications. The auditor should himself randomly pick up the garments from each checker's past pieces. These pieces should not be given to him by the supervisor or any other personnel. He should do an audit of each checker at least 4 times a day in order to get a representative checking efficiency of the checker. The formula for checking efficiency of checker is checking efficiency is equal to 100% inspection DHU multiplied by 100 divided by 100% DHU plus quality audit DHU, where DHU is defects per 100 unit. For washing finishing audit, emphasis not should be given to areas affected by washing or finishing, that is trimming holes, fraying at the collar due to washing, etc. Quality audit is an everyday process and should be undertaken without fail. Here some of the sections where I am just want to explain about some of the terms, which is one term is known as quality drill, which normally in sewing floor this used to take place. The quality drill where the production supervisor is responsible of the operator's work, so it is of utmost important that he or she has control over the quality level at which the operators produce. To prevent repairs or to ensure good quality, there is a useful tool called quality drill. It is very effective in making operators quality conscious. During this exercise, you confirm to the operator the commitment of good quality that company has made motivated him to produce with quality. The procedure is the following. Ask the operator to stop what he is doing and stand up. Give the masking tape to mark defects. Ask the operator to inspect based on quality specification the bundle in which he is working on, the bundle he has already finished, and the bundle he is going to work on next. This way, the operator has the chance to see if the work he is doing is of good quality and also make sure that the work he is receiving from the previous operation is not defective. Ask the operator to mark any part that is out of tolerance with the tape. Then ask the operator to do it while standing up, and when he or she is finished, he should signal the supervisor that he is ready to have the results evaluated. The supervisor makes sure that the instructions have been understood and then leaves to continue with the regular activities. When the operator in fact has signaled that he is finished, the supervisor returns. The supervisor then proceeds to inspect at random a number of parts of any bundle. If he is to find a defective part, he should separate it and ask the operator why the part was not identified. If there is no defective part found by the supervisor, he turns to the operator and asks operator to show him the defective parts he found. So, in this case, the operator is going through this exercise of quality drill. After this, if the operator has found no defects, then supervisor should select a part and ask the operator to explain why this part is of acceptable quality. The operator should be able to explain why based on the points described in the quality specification. Next, if object defective parts have been identified, then operator should explain why they are defective based on points described in the quality specification. If the supervisor notices that the operator is not very clear of he what the requirements for his operation are, or how to find out if these requirements have been met or not, then the quality specification sheet should be reviewed point by point. If the supervisor notices that the operator overlooks the defects, then the supervisor should review with them the importance of doing a job properly every time. The contact that a supervisor and the operator have during the quality drill is very valuable. During this time, the commitment of everyone to guarantee a job well done is strengthened. At this time, the operator should be encouraged to learn what the requirements for his operation are, and he is complimented if he knows them wholeheartedly and works to achieve them every time. This exercise should be performed on standard time and at least once a day. If you are having quality problems with an operator, you should increase the frequency of exercise even to one exercise an hour also. It is necessary that the trainer and the supervisor explains the importance of quality drill to the operators, stressing that its sole purpose is to help them improve their quality. The initial resistance by the operators is normal, but as soon as positive results from the exercise are seen, the operators will take the initiative to do the exercise themselves. In the garment industry, quality control is practiced right from the initial stage of sourcing of raw materials to the stage of finished garment. For textile and apparel industry, product quality is calculated in terms of quality and standards of fiber, yarns, fabric construction, color fastness, surface designs, and final finished garment products. However, quality expectations for export are related to the type of customer segments and the retail outlets. There are a number of factors on which quality fitness of garment industry is best, such as performance, reliability, durability, visual and perceived quality of the garment. Quality needs to be defined in terms of a particular framework of cost. The National Regulatory Quality Certification and international quality programs like ISO 9000 series lay down the broad quality parameters based on which companies maintain the export quality in the garment and apparel industry. Here we will be discussing about different types of major and minor defects in garments manufacturing. There is first will be source of the defects, second will be the description of defects, third will be the defect categories, whether this is major or this comes under the minors. The source of the defect, if you talk in garment manufacturing, especially during sewing and just before the sewing, we talk about the fusing. The source of the defect is fusing. The description of defects are if bubbling occurs to fusing, and the type of the defect is basically major. If in the fusing discoloration occurs, that also comes under the major defect. If fusing gum is visible from outside, this also comes and falls under the major defect. Now source of the defect has been changed to zipper. If the zipper type and color is wrong, like suppose in the zipper type, in the place of invisible zipper we have used exposed zipper, or color we wanted to have the DTM, that is dye to match color, and we have used some other color, or Pantone number is wrong. So if zipper type and color is wrong, this comes under the major defect. If slider is defective, that also comes under the major defect. The slider of the zipper is defective, that comes under the major defect. If the size of the zipper is wrong, size of the zipper is either more or less, then in both the cases this comes under the major defect. And if zipper is not well attached with the garment or with the fabric, then that also comes under the major defect. Now next source of defect is button. And the description of defects are if button not securely attached. It is not attached securely, whether we are using the lock stitch or we are using the chain stitch. If it is not secured properly, then there is always chance of unraveling of the button. So this comes under the major defect. If wrong buttons attached, if button which was supposed to be attached, which is used, wrong button has been used in that particular place in terms of content of the button, in terms of color of the button, in terms of the line of the button, that's the size of the button, so that also comes under the major defect. Missing functional buttons. If center front of a shirt needs certain amount of the buttons and one button is missing out there, so those functional buttons, because this is called the functional buttons, and those buttons, missing of the functional buttons, will fall under the category of major defect. Missing decorative button, for zone B it's a minor, for zone A it's a major. So if it is in zone A and that defect is in zone A, although the button is a decorative button, that comes under the major defect. Misaligned button, if the button is misaligned, it's not aligned properly, and if it falls in zone A, then that comes under the major defect. But if that misaligned button comes under zone B, then it comes under the minor defect. Next is functional or decorative button insecurities shown. That the button, whether the button is functional or decorative button, which is not secured properly. So this is comes under the major defect. Next is size, type and color is not as per specified, then that also the button in that particular category comes under the major defect. Damaged button, if the button is damaged, it's a broken, or the button is having the some manufacturing defect, so damaged button comes under the major defect. Next is buttonhole. If the buttonhole is not completed properly, is incomplete, so that's called major defect. If the buttonhole is cut, that also is a major defect. If the buttonhole is not aligned, that also comes under the major defect. Missing functional buttonhole or missing decorative buttonhole. In the case of zone B, it's a minor, but missing decorative buttonhole in the case of zone A, it is called major. Misaligned buttonhole, the buttonhole is not aligned in terms of zone A, this is called the major. In terms of zone B, it comes under the minor. Extra buttonhole. If extra buttonhole is required, and that is, so in this case extra buttonhole comes under the major. Broken or skipped stitch in the buttonhole. The stitch is broken or skip stitches in the buttonhole, that's come under the major category. Next is velcro. Wrong velcro attached comes under the major category. Defective velcro also comes under the major category. Wrong velcro size is also the size is wrong, that is not as per the specification sheet, then this also comes under the wrong velcro in the major defect. Velcro misplaced is also comes under the major defect. Snap button. Snap button attached incorrectly will come under the major defect. Wrong snap button attached also will be part of the major defect. Defective snap button is a major defect. Then eyelet, grommet, buckle, etc. If it is attached incorrectly, then this comes under the major defect. If omitted or if defective, then that also comes under the major defect. Two shaded parts are sewn together, that also comes under the major defect. If wrinkle appearance during the sewing, then it will spoil the whole garment, so this also comes under the major defect. If stripe is not aligned, it comes under the major defect. If draw cord, tape, etc. do not move easily, this is also the major construction defect. If wrong size or type things are attached, that also comes under the major defect. The next is seam or a stitch. So miss in this stitch type is incorrect, that is the major defect. SPI, that stitches per inch, is not correct. If we need the SPI of 9 or 10, Suppose 10 SPI we need and we have given the actual SPI is 14, so that's not a correct. So SPI incorrect is comes under major defect. Broken stitch, wrong inlay or stripe on or check not matching during the placket, during the pocket, during the cups, during the collar. So wherever the whatever the matching parameters are there, if the stripes and checks are not matching, then it will be fall under the defect, and those defects will be known as major defects. Wrong seam. If the seam is wrong, then the defect is major defect. Thread not matching. If the thread is not matching with the fabric or with the garment, then that is a major defect. Defect repaired incorrectly. If the defect has been repaired incorrectly, then that also major defect. Defects like puckering, twisting, waving, etc. present major defect. Open seam present major defect. Overlap stitching, if it occur in zone B, then it's minor. If the overlap of stitching in zone A, that's called as major. Double stitching, this also comes under the stitch and seaming. Then pockets and cuffs. If top stitch not done gracefully in the pockets or cuffs, then it comes under the major defect. If up or down, the position is up or down, the pocket position is up or down, or cuff position is up and down, then this is the major defect. Absence of back stitch will also comes under the major defect category. Shade and color. Offset or mismatched color, in both the case, this comes under the major defect. Then if the label is missing, the case of label, if label is misplaced, incomplete label, wrong label, insecurely attached, so these all different types of the labels will come under this category. Then during the pressing also, overpressed, distorted, wrinkles, these all three are basically comes under the pressing, and pressing has the problem in this case. Construction and stitching. Any rise which is visible, if repair result in good appearance, major defect. If seam shows poor appearance, this is a major defect. If length hole present, this is major defect. Wrong embroidery, up and down or misplaced, weak attachment of lining or facing result in poor appearance, this comes under the major defect. Drill hole, notches visible, if a placket is visible, twisted, if stitch tension too tight, broken stitch in the chain stitch seam, broken or skip stitch present and visible, if bar track is misplaced, and if bar tack is omitted. So these comes under the category of where it's a construction and stitching category. Sewing is the process of attaching two fabric parts by using stitches, which is made of a needle and thread. Sewing is one of the basic steps of garment manufacturing process. Also, sewing section is the most significant section of a ready-made garment industry. Different types of faults or defects arise in sewing section which should be reduced to maintain the required quality of apparel. As its importance to see all the defects which produced in sewing section of garment manufacturing factory. The types of the defects found in sewing section. The defects, sewing defects are needle damage, for example, thread drawn off from the fabric or making of large hole to the fabrics, skipped stitch, thread drawn off, seam puckering, wrong stitch density, uneven stitch, staggered stitch, defected stitch, oil spot or stain, seaming defects, uneven width, uneven seam line, not secured by back stitch, twisting, no matching of check or stripe, no matching of seam, unexpected materials are attached with the sewing, not sewn by matching face side or back side of fabrics, use of wrong stitch type, wrong shade matching of sewing thread. Assembly defects. Defected finished components by size, that is imperfect size and shape of finished components. Imperfect garments size, use of wrong ticket, missing of any parts or predetermined design of garments, imperfect alignment of components, that is button, hook or so on in proper place, wrong placing or creasing of interlining, looseness or tightness of interlining, folding of any parts of garments that is seen to bad appearance, shade variation of garments, false direction of fabric parts in the garment, imperfect matching of trimmings in the garment.
Today we are going to see the troubleshoot in sieving, construction of seams. First we are going to see SPI. In 1 inch we have to count. So this is 1, 2, 3, 4, 5, 6. We got 6 stitches. Next, one, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10. You have to change the stitch style. For 6 I kept it at 4, SPI 4. For this I kept it at 2.5. Next, we want 12. So I'll keep it at 10. I'll keep it at 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. So we made 3, 12, 10, 6. The SPI for this is 4. SPI for this 10 stitches is 2.5. For SPI for 12 stitches is 2. So this is the preferred one. We should get 12 stitches. That is 2.5. You have to keep 2.5. Stitch per inch is 2.5. You have to keep your stitch style at 2.5. We made 3 rows of stitches. First one is 6 stitches within this inch. Per inch we got 6 stitches. We have to keep your stitch style at 4. Next is we got 10 stitches per inch. We have to keep your stitch style at 2.5. Third is we got 12 stitches per inch. That means you have to keep your stitch style at 2. So the preferred one is 10. 10 stitches you have to get within the inch. We made 3 rows of stitches. In first row we got 6 stitches. In second row we got 10 stitches. In third row we got 12 stitches per inch. You have to keep your stitch style 2. This is 2.5. This is 4. The specification given for this is 10. You have to get 10 stitches per inch. We made a row of stitches. We got a cut here. This is known as stitch cutting part. Because of tension we'll get. Stitch cutting. So this is a normal stitch with back tack we made, so the seam won't get open. Here I made without back tack, so the seam will get open. So this is open seam. Sometimes middle also the thread will get the gap. So this is open seam. We made 2 rows of stitches. You can see overlapping at this part. This is known as overlapping stitch. At some point it suddenly got overlap, but usually we have to maintain this distance. By mistake we got this overlap, so this is known as overlap stitch. We made double stitch. Actually we have to use the foot so that we get the distance proper, and the stitch intake stitch length also it should be proper, but we made 2 times, so we are getting the distance difference, and the stitch length also will get difference, so you have to use a proper foot. So this is known as double stitch. As puckering, if the tension is not correct we'll get this effect. If needle is so thick also we'll get this. The stitch is not flat, you can see the wavy effect. So this is known as puckering stitch. Now we're going to see thread matching. The shades will be differ. Dye to match thread. One is contrast. Dye to match we'll use for a formal stitches, formal trouser, top stitching, whatever top stitching. Another is contrast thread matching. Usually it's used in a casual wear, denim trousers, contrast top stitch will make. So first I'll show you mismatching thread shades. You can see the variation of shade of the green color. This thread color is bit different comparing to the shell fabric. Now we are going to see contrast top stitching. You can use contrast top stitching. They'll use thicker thread. Usually the top contrast top stitching is used in a casual wear. This is mismatch thread shade. This is contrast top stitching. Now we gave a bottom edge stitch. You can see a twisting here. It should be a flat, but you got some twist here. So this is known as twisting. You got a twist here. It should be flat. It's occurred some twist here. So this is known as twisting.